This is section 2.9, the final section of chapter 2. It's probably the most difficult section in all of Algebra 1. Okay, so you guys need to pay attention. Get your notebooks out, copy some stuff down. This is your title, 2.9 weighted averages. We're going to move right along. Slide right here. We're going to be dealing with mixture problems. And the bottom line, a mixture problem, when you take one thing and mix it with another, you're really adding them together to get your new mixture. So keep that in mind, that on most of these problems, we're going to be taking something, mixing it with something else, putting them together, adding them, and then getting your new mixture. So right here, our first example, it says Miss Matthews has 16 cups of punch that is 3% pineapple. Okay, 3% pineapple juice. That kind of tastes like water. She also has punch that's 33% pineapple juice. That's definitely way stronger than 3% pineapple juice. How many cups of 33% punch will she need to add to the 3% punch to obtain a punch that's 20% pineapple juice?
17.
Pineapple pen. What? No. This does sound very confusing because it is. What we need to do is to figure out how we're going to do this mixture problem. And this is the way I would set it up. Okay, guys, so please jot this down. Write down, remember, a mixture problem, we're going to take something and mix it with something else. That means we're going to add them together, and we're going to get a new amount with a new percent mix, a new percent strength. So write down percent amount plus percent amount equals percent with the total amount. Okay? So let's start out with what this says right here. It says the 16 cups, that could be 16 gallons, it could be 16 ounces. That's the amount, right? That's the amount on this first one. And it's 3% strong. Now, our calculators do decimals. So instead of the percent, what am I going to put right there? Instead of 3%, what am I going to put? 0.03. Good. So that's our percent. Now, how much? What's the amount of that 3% juice? It says 16 cups, correct? So I have 16 right here. Okay. So once again, let's read. It says she has 16 cups that's 3%. Like I said, that tastes like water, right? She also has punch that's 33% pineapple juice. That's stronger, definitely stronger. Now the question is, if I zoom out a little, it says how many cups of the 33%, the stronger juice, does she need to add to the weaker juice? How many cups? This is the stronger that we're going to add. So how many cups do we need to add of the stronger juice? How strong is it, by the way? 33%. So when we put the percent on this one, we're going to put 33, which is a 0.33. Sorry, it's getting ugly. And it says how much do we need to add? How much? The amount. Do we know the amount? No. So what am I going to put right there? X. Okay? Now, we know that when we mix them together, wait, let me write this in red, the equal sign in red. Wow, that's really ugly. I'm sorry. We know that the new amount, we want it to be what? If you keep reading this thing, it says how much does she need to add of the 33% to the 3% to obtain a punch that is 20% pineapple juice. So we want this weak tasting pineapple juice to get a little stronger by adding the stronger one, and we want it to be 20% strong. That's probably the best tasting pineapple juice. So we're going to make it 20% strong. Does that make sense? But the deal is, we still need this new total amount. So we still need this new total amount over here. Now the thing is this first amount we know is 16 cups. Now it says how many cups do we need to add? We don't know. That's why we put an X right there. So the original was 16, but I'm going to add X to it, and that's how I'm going to get my new total amount. So what's my new total amount going to be? It's going to be the 16 plus X. you should, if you're watching this at home, you should pause it right there and try to make sense of this equation. All right? You have to make sense of this. Once again, you have your weak tasting 3% juice. We know it's 16 cups. That's the amount. Could be 16 gallons. Could be 16 quarts, whatever. That's just the amount. This is the strength. 3%, 16 cups of it. Now it says we need to add the stronger 33% juice. Now the question is, how much do we need to add of the 33? How much do we need to add to the original, right, to get a nice 20% tasting juice? So here's the 3%. There's 16 cups of it. I don't know how much of the 33% I'm going to add, but I do know that I want it to be a nice 20% tasting pineapple juice drink. And my new total amount will be this amount plus this amount that I don't even know yet. So my new total amount is going to be 16 plus X. Does that make sense? To two people, nobody else.
Yes.
Okay. So the question was, this 33, I put it right there. I know it came out ugly. Let me zoom it in. Let me do this. 33 point. Is that better? No, it's uglier. I'm sorry. But you guys get the idea, right? That's your 33% juice. So at this point, you need a calculator. These equations are very difficult to work with. Actually, I don't have a calculator. I'm going to have to rely on you guys. So let's take a look at this equation that we set up. And please help me out here with the calculator. What is the 3% but as a decimal? 0.03 times 16. Help me out. Point what?
0.48.
Okay, 0.48. And over here we have a 0.33 times x. I'm just going to put plus 0.33x. Is everybody with me? The equal sign comes down. Let me move the screen over a little. Now over here is a little bit more challenging part. I need to take this 0.20 and distribute it to both terms. So with the calculator, 0.20 times 16, help me out. That's point what? 3.2? 3.2, not 0.32. Okay, so let me erase this decimal. There we go. And finally, when I distribute to the other one, 0.20 times, bless you, x, that's going to be plus 0.20x, or you could just put 0.2x. So does everybody understand what I've done so far? I just simplified. And now it's a question of solving. I need to solve for x. Where's my x at? The left side of the equal sign or the right side of the equal sign? It's on both sides. I don't want it on both sides, so I'm going to get rid of one of them. I'm going to subtract 0.20x. That's like saying subtracting 20 cents. That cancels out. What I do to one side, I have to do to the other side, subtract 20 cents over here, 0.20x. And right there, 33 cents, take away 20 cents is 0.13, and that is terms of x. Let's bring down everything else, the plus, the 0.48, the equal sign, and the 3.2. So I'm almost done solving this thing. I just need to get it by itself, get the x by itself. So I subtract 0.48, and what I do to one side, I do to the other. So I'm going to subtract 0.48. So that's kind of like having $3.20 take away 48 cents. What's the answer there, guys?
2.72.
Okay, so 2.72, and I'm going to bring down the equal sign right here, and I'm going to bring down the, this canceled out, I'm going to bring down the 0.13x, and now all I have to do is get that x by itself by getting rid of the, this is a point, not a negative, by the 0.13 in front of the x. So I'm going to divide by 0.13, so it'll cancel, divide by 0.13, and go ahead and do that on a calculator. 2.72 divided by 0.13, x equals 20.92. Okay, so I'm going to say that my x, since we're talking about cups, is about 21 cups. Okay, so once again, what did we just find? We found x. Now, what is X? Check out the original equation. X is the amount of the 33% strong juice that I added to my weak juice. So the answer is I need to add about 21 cups of the 33% strong juice to the existing 16 cups of 3% juice to get my nice mix, which is 20% juice of this new total amount, which would technically be 16 plus 21. This would be a bigger value over here. But the question is, how much do I need to add? I need to add 21 cups of it. You got it? I hope. So on these mixture problems, we just had a question, how do I know what to plug in where? If you get comfortable with this setup, percent of something plus percent of something equals a new percent of something, everything will fall into place. Let's take a look at the next example to show you how it falls into place.